Okay, for those who started the normal probability worksheet that some of you had with a sub and some of you had with me, most of you figured out number 1 and 2 the easiest way, which is appropriate for the AP exam, is to use the normal CDF command under second distribs on your TI-84, and you always put your lower bound to your upper bound. In other words, on that curve, this would be like a lower bound, and this might be the upper bound, and you are shading in this area here. This will find the area under that curve. Now, on this curve, of course, you're also going to be able to need to know what the mean, and I'm going to call mean mu, because that's a large population, and the standard deviation I'm going to call sigma. So you key that in specifically for each curve, and it works every single time. Let me just do one right here just to show you what it would look like in 2A. 2A. What is the probability that randomly selected, it should be tank, not think, tank will hold at least 16.15 gallons. So I draw my normal curve. I'm always going to look at it, and I read in the problem that the tank had a mean of 16. That always has to be here in the middle. If the standard deviation was 0.1, just by using 3 standard deviations, that's 16.1, this one is 16.2, and this one is 16.3. That takes you 3 standard deviations to the right. Take 0.1 away each time, 15.9, 15.8, and 15.7. And we want to find out in A, what's the probability that tank will at least 16.15. So 16.15 must be between the 0.1 and the 0.2. So it's somewhere in here. At least implies greater than or equal to 16.15. So that would be the blue shade. So my calculator would be normal CDF. And I'm going from at least that, so it's pause. Okay, where was I? We were using normal CDF, and the lower limit was 16.15. The upper limit will be everything to infinity. So just pick a big number like 99999. And then if you're going to a lower limit as infinity, let's pretend for a minute you were going to go this way, then you would use your lower limit would be a negative 9999. Then your upper limit would be wherever you wanted to go, okay? But in this case, my standard deviation and mean, I had to plug that in, so that was 16, comma, and 0.1. So you key that in, second distribs, normal CDF, you'll see it at the top of the list. And you'll do all of those. You've got to figure out which way am I going? Am I going between 2 numbers? Then you got lower limit here, upper limit here. Okay, now, if you watch the videos, you should be able to do all those problems. But the problem came with number 3, and maybe even one later. But they reversed it. They're doing the percentile now. Instead, it's in reverse. You're looking at a problem where it says a student, I'm doing A, wants to be in the top 50%. Well, top 50% would mean definitely to the right of the mean. to the right of mu, that's the top 50%, because the mean and the median are in the same place if it's a perfectly symmetrical normal curve. So that was not in the videos. So in your videos, to do that particular work, it's still under second distribs, which, by the way, distribs is above the word vars. That's number 3. Second distribs number 3 is inverse norm. In this case, you just tell it, well, what area do I want? Well, in this case, I want 50% of the area. Okay? I want 50% of the area because that's the area to the left, which is also 50%. We always key in, like I want the value of what the score has to be in the 50%. And it's going to be an easy problem because we already know what the mean is, and the mean's in the same place. But just for fun, I will say I want 0.5 area, and then I have to put in the mu, and then I have to put in the standard deviation. So the mu was, the mean is 18. Standard deviation is 6. So that'll give you what score would be at this place right here, right here. That'll give you this score. Okay? That's A. Let's look at B. What score would a student need to be in the top 10%? Looking at the same picture. If you're in the top 10%, you are in here. So I want to know what that score would be here. I do know still that the mean was still 18. And then that would be a 24, and that would be a 30, and that would be a 36, and that would be a 12, a 6, and a 0 if I use those 6 tick marks left and right of the mean. But I still want to know what this value is right here. So again, you have to ask yourself a question. What's the area to the left of it? The area to the left is going to be 90% because this is the top 10%. So the work is going to look like this in your calculator. Inverse norm. What area? 0.9, because that's the area to the left, comma 18, comma 6. Bingo. It will give you the score, and it should be higher than 18. It should be higher than 18. And this score, letter A, I didn't mention it, but the score probably should be 18 because that's exactly in the middle. That's the median. Let's see, the third one, C, top 10%, to be in the, oh, the word percentile, that's going to cause you some problems. It just means what percent is lower than the student. So what score would the student need to be in the top 10 percentile? Well, let me write again. The 10 percentile. Make sure I get it right. I want to be in that percentile. What score would the student need to be in the 99th percentile? Draw the picture. What score would you need to be in the top 10%? Remember, 18 is the mean, 24 is one standard deviation, 30 is another, that's 2 standard deviations, 36, 12, 6, and 0. So what would I need to be in the, let me read, that means only 10% did worse than you. So I need a tail here where that's 10%. So I'm looking at a score here, and I don't know if it's 6 or lower than 6. I think it's lower than 6, I think. But anyway, I'm not going to, well, I will, I'm going to type this when I'm curious. Inverse norm, I want 10% of the area. 18 is the mean and 6 is the standard deviation. I'm going to key that in just for kicks, just to see what it is. Inverse norm, and the area is, in this case, 0.1. Typing in that is a menu, and mu is 18, sigma is 6, and I hit paste it, and then when I hit paste it, it looks exactly like what I just wrote down, and I hit enter, and okay, it's higher than I was thinking. It comes out to 10.3106. So if I want to be in, I got to read the question correct, means what I'm really looking for is the probability that x is less than or equal to 0.1. So that is less than 10%. Actually, I did that wrong. That x is less than or equal to 10.3. That's what I should have put. X is less than or equal to 10.3106 will be less than or equal to 10%. So let's just call it a 10. Anything lower than 10, so this number, it's actually going to be where that blue line is, it's actually a 10.03. Anything in here, you'll be in that 10 percentile. One more, and I'm calling it, that's a better place to be. 99 percentile, that means only 1% did better than you. 99% did worse than you. So that's inverse norm, 0.99 to the left, and comma, 18, comma 6. And whatever your score is, x has to be greater than or equal to that answer, because I want to be in the top 1%. The top 1%. Okay, I'm calling it quits, and the rest of you will be on your own. I'm going to post this so you can finish this worksheet next time I see you, by the time I see you. Adios. Hasta luego.